Salam alaikum. How are you guys? Nice to see you all again. Salam alaikum. Let me see. Wait a minute, guys. I'm gonna be back. Prayer time, apparently. Guys, do you have my audio? There. Salam alaikum, everybody. I hope you're having a good time. I hope that you haven't abandoned studying. Uh, I don't. Let me see how many of you guys are online. I guess around 24 of you, which is a good number. It means that we are ready to start. Let us start by doing presence and absence. Uh, 23 are present. Okay, no problem. I'm gonna add them to the list. So, Ibrahim Khalil, yes. Ibrahim Farhan, Ibrahim Farhan. Ahmad Halgord, Osame, Osame Osman. Oh, really? Okay. Ismail, okay, okay. But in the meanwhile, we have nothing to do. So let us first put you guys who are present here, and we're gonna think about the ones who are absent later. Okay. Ismail, do you hear me? خب ایمان بلند بلند ها بیلال ایمان. So, Ibrahim, Ahmad, Bilal, are you there? Very well. Balen, are you there? Very well. Tara, is she around? Jariye, Jariye is here. Delwan, very well. Rikan, he was here. Zakaria, very well. Saeed, Shahram, Shahram, I'm seeing him. Shuan, very well. Sobhi, do we have Sobhi? Very well. Salam alaikum. Abbas, I saw him. Muhammad Ibrahim, very well. Muhammad Abdullah, Muhammad, very good. Muhammad Farhad, do we have Muhammad Farhad or not? Okay. Mahmoud Tahsin, do we have Mahmoud Tahsin? Muslim, we have him. Hevin, we have him. Helene, are you there? Very well. Halvest, are you there? Salam alaikum. Yusuf, Yusuf, are you there? Oh, really? Oh, may she rest in peace. No problem, no problem. And I have to do presence and absence, but uh, this is just a routine. I don't think somebody's gonna. Okay, this is just a routine we have to go through, and as the sooner we do it, the better. Avar, do you hear me? Avar, very well. Zana, Zana, Goran, do you hear me? Oh, okay, a little bit too late. Okay, thank you guys. So, let us start uh, with the lecture that I'm going to give you. As you all know, and as you all can see, the tools that we have at our disposal to present the lecture to you are very limited. Uh, I don't have a tablet with a stylus pen, and we don't have a board and stuff like that. Mm, we don't have a very good recording equipment. But in the previous classes that we conducted using this platform, I think the students were happy and the results were good. So The only thing that we can do at the moment is for me to show you the lecture notes and try to explain to you what is going on while you're looking at the lecture notes. The thing that you need to do here is to be focused on the screen that I'm going to share with you, and uh, you have to listen very carefully to what I say and try to trace it uh, in the screen that is going to be shared with you. And if you have any questions, feel free to interrupt me, okay? And I'm gonna try. I'm gonna do my best to try to explain to you and try to clear up your question. And at the yes, all of it is. It is exactly what I was going to say. Uh, I am recording what is going on, and I'm gonna send to you a recorded version of the lecture that we're having. I'm gonna upload it on YouTube maybe, and you're gonna have the ability to listen to the lecture over and over again, go through this stuff over and over again, and uh, get a good grip of what is going on in the lecture that we are having right now. So, some of you are texting me here. Ismail is also present. Yes. I changed your status in the presence and absence list, Ismail. Uh, Ibrahim Farhan has also arrived. Yeah, it is okay. Now, guys, in the okay, no problem. Okay, I'm gonna put in presence for him. Okay, you're gonna see. You're gonna see. You're gonna see. We don't have the ability. I don't have a whiteboard at my home. Yeah, there are lots of other better possibilities, but we don't have that equipment here now in a quarantine. Uh, but don't worry, Mr. Saeed. You worry too much. Don't worry, it is going to be perfect. I'm not worried about that at all, and I promise you, you're gonna understand what is going on. Now, guys, where were we? The previous lecture that we had was spent on. Sorry, let me silence the source of the noise. Okay, are you hearing me, guys? So now I'm gonna share my screen with you. Now, do you all see this? Very well. Very well. Now, in the previous lectures that we had together, the last topic that we covered was the topic of implicit differentiation, right? Now, that chapter is over, and in this chapter, we're going to cover the subject of integration. I have sent you the lecture notes for this chapter previously before the quarantine happened. If you have missed it, if you have lost it, uh, you can go to your LMS system, learning management system, and you can go to your learning management system, and over there you find all the lecture notes that you need to have for this course. Guys, I'm not sure whether or not you're hearing me all right. If you hear me, please say something. Some of some of you. Oh, very good. Perfect. Very good. So, guys, the subject of integration starts with a concept which we call the concept of antiderivative. You are all familiar with with the subject of integration and all this stuff that I'm teaching you right now. So we try to go through this stuff a little bit faster than usual. And when we get to the points that may be new to you, we're gonna spend more time and effort there. Okay? So how do we define the antiderivative for a function? As the name implies, the antiderivative is going to be something similar to the opposite of derivative. A function f, here you see the capital letter f, is an antiderivative of lowercase f on an interval I if f prime of x is equal to f of x for all x in I. What does that mean? That means here we have a function which we call lowercase f, as you see here on the screen. The function f, uppercase f, for which the derivative is equal to f, is called the antiderivative for the function f that we have in mind, right? So the process of recovering a function f of x from its derivative f of x is called anti-differentiation. And the result of this process is a function f that we call the antiderivative of f. Okay? So questions. Guys, go ahead. Somebody wanted to say something. Guys, are you hearing me? What? What, Ismail? I'm hearing you. I hear you, yes. You don't hear me? Oh, okay. Very well. Alhamdulillah, no problem. So, example 1. Find an antiderivative for each of the following functions. We have a function f of x equal to 2x. We want to find an antiderivative for this. What does it mean? It means that we want to find a function like f for which the derivative is equal to 2x. What is that function? as you all can easily answer me, that function is going to be x2, right? But exactly, exactly. That is what we're going to say in a moment. But that is not the only function for which the derivative is equal to 2x. It is x2 plus 1 also is a function for which the derivative is equal to 2x. x2 plus 2 is also a function for which the derivative is equal to 2x. And for that matter, x2 plus any constant is a function for which the derivative is equal to 2x. So the antiderivative of a specific function that we consider is not unique. Okay? It's not unique. So if we have a function like f of x equal to sine of x, the antiderivative for it is equal to minus cosine of x, right? Now, if here you decide to check the answer that you have in mind, you can check the answer that you have found for the antiderivative of a specific function by derivation, right? So the derivative of minus cosine of x is equal to sine of x. Yes, so capital case f equal to minus cosine of x is the antiderivative for f of x equal to sine of x. Yes, and the derivative of x2 is equal to 2x. So x2 is a correct antiderivative for is actually an antiderivative for 2x, right? As we just said, the function the function f of x equal to x2 is not the only function whose derivative is 2x. The function x2 plus 1 has also the same derivative. So does x2 plus c for any constant c. Yes? Guys, are you with me? Very good. But the question that comes to mind at this point is, are there any other antiderivatives for the function 2x? Huh? Maybe we can find a very weird function e to the ln of uh, tangent of something very weird, something very big and ugly, that the derivative for it is accidentally is equal to 2x. Huh? That is a question. We might be able to find such a function or not, right? So the theorem that you have here says if f is an antiderivative of f on the interval I, then the most general antiderivative of f on I is f of x plus c, where c is an arbitrary constant. This theorem that you see here is a very important theorem. Why? Because it tells you that if you find an antiderivative for a function, even by accident, then that antiderivative plus a constant is gonna constitute a family of functions which includes all the antiderivatives for the function that you have. Huh? That is the importance of this theorem that you see here. So the function x2 plus c, where c is an arbitrary constant, forms form all the antiderivatives of f of x equal to 2x, right? Questions? Very good. So, the most general antiderivative of f on I is a family of functions, capital case f plus c, whose graphs are vertical translations of one another. We can select a particular antiderivative from this family by assigning a specific value to c, right? So, what does that mean? Consider the function f of x equal to 2x again, right? If you consider all the functions that are the antiderivatives for this specific function, for example, x2, x2 plus 1, x2 plus 2, x2 plus 3, right? Or the whole family x2 plus c. These functions, now look at me guys, these functions are vertical translations of one another, right? If you draw the graph for x2, the graph for x2 plus a positive number is going to be a translation, vertical translation upwards. The graph of x2 plus c, where c is a negative constant, is going to be a vertical translation downwards, right? And the important point here, guys, look at me. The important point here is that by choosing the value for the constant c, you point to one of the members of this family of antiderivatives for the function that you had in mind. Okay? So for every c that you choose, you can define an antiderivative, you can have an antiderivative for the function that you had in mind. Yes? Guys, any questions? Now we're going to solve an example.
Teacher, where are you go?
Where are you? The Zoom hanged on me. It got shut down, and I loaded the software again. Okay, guys. Now we're gonna solve an example here. It says find an antiderivative. Do you see it? It says find an antiderivative of f of x equal to 3x2 that satisfies f at 1 equal to minus 1, right? It is very easy to do. Now, we have to find a function for which the derivative is equal to 3x2. By using the knowledge that you have from high school, you can say that it is a function like x3 plus c, right? But this general antiderivative that we have found has a constant c in it, which is undetermined, right? And we have to determine C in a way that the value of the antiderivative at point 1 becomes minus 1, right? Now, how do we find such a C? In this equation, for the general antiderivative that we have, instead of x, we put in 1, and this condition that is given to us here tells us that f of 1 has to be equal to minus 1, right? So minus 1 has to be equal to 1 plus c. That means c has to be equal to minus 2, right? So f of x has to be equal to x3 minus 2. Yes? علیک السلام. اوقار بخیر.
Welcome, welcome. بخير أخيرا.
No problem. No problem. So guys, you see here, this graph that we have here is very informative. The general antiderivative that we had was x3 plus c. In this graph that you see in page 3 of your lecture note, has drawn the graph for the function x3 plus c for various values of c, right? For c equal to 2, for c equal to 1, for c equal to 0, for c equal to minus 1, for c equal to minus 2. You could have drawn the graph for any value of c, but it has chosen to some specific integers to give you a good understanding. Now, this initial condition that is given to us here, which tells us f at 1 is equal to minus 1, actually means that at x equal to 1, the antiderivative that we're going to find has to pass through the point minus 1, right? So this red point that you see here is the meaning.
Axis,
What?
y-axis.
This is the y-axis, right? This is the x-axis, right? And in the question, it tells us that find a specific antiderivative for which, here, for which f of 1 is equal to minus 1. What does that mean? That means the graph for the antiderivative that we're gonna find has to be such that it passes through the point 1 minus 1, right? The graph for the antiderivative that we're going to find has to be such that it passes through the point 1 minus 1, right? Now, from all from all the members of this family of antiderivatives that we have found, there's only one member that has a graph that passes through the point 1 minus 1. And that member is the member that has c equal to minus 2, right? Other graphs here that you see in blue are also representative of functions that are the antiderivatives for 3x2, but they don't satisfy the condition if at 1 equal to minus 1, right? Meaning their graph doesn't pass through this specific point that you see, right? Questions? Okay, guys, listen to me. I'm gonna stop this broadcast here right now, and I'm gonna send you another link for our next session. Okay?
Teacher, one
What?
minute, teacher.
What?
Teacher, can you change the app? WebEx is better.
I haven't.
Antiderivatives.
I've heard that it is better, but I haven't personally used it up to now. So I don't know how to send the invitations to you via WebEx, right?
Just send us a link and I will share it. No problem. Just send email and
Okay. Okay. Let's see what's gonna happen. Okay. So we're gonna end it now. See you again soon. So guys, we were we were solving example 3 of the second chapter. It says find the general antiderivative of each of the following functions, right? When it says the general antiderivative, it means the most general antiderivative, right? The one that has c in it. Now, for the function f of x equal to 2x, as we just saw, the most general antiderivative would be x2 plus c. For the function x2, the most general antiderivative, if you have no previous familiarity with the subject, at this point, you're looking for a function for which the derivative is equal to x2, and that would be x3 over 3. According to the first theorem that we saw, by finding one antiderivative, we actually find the most general antiderivative for the function that we have in mind very easily. And it is by adding just a constant to the random antiderivative that we have found. So the most general antiderivative for the function f of x equal to x2 would be x3 over 3 plus a constant c, right? Now, for f of x equal to sine of x, the most general antiderivative is going to be minus cosine of x plus c, right? The derivative of minus cosine of x plus c is sine of x. For the function f of x equal to e to the x, and this one is very important. Oh, really? What about the others?
what, teacher, what?
Goran, do you hear me clearly?
Yeah, teacher, I hear you clearly.
Oh, very good. So that might be because of the quality of your internet connection.
أنا تقول نعم.
What? Oh, yes. I know, but don't worry about that. I'm gonna give you the recorded version of this lecture very soon. And in the recorded version, there's gonna be little to no noise because we are recording the system audio, not the audio that you're receiving via internet connection. Okay? So even if your audio quality is not perfect, I think it might be because of your internet connection quality, because here I have a very good internet connection. But anyway, if you don't hear me perfectly, don't worry. I'm going to give you a recorded version of this lecture, and over there the audio is going to be fine. Okay? Now, for the function f of x equal to e to the x, the antiderivative is what? We're going to find a function for which the derivative is equal to e to the x. Huh? Okay? And what is that function? That function is the exponential function itself, right? In the previous chapter that you saw that the derivative for the exponential, for the natural exponential function is itself. And actually that was our criteria to define the number e, right? We chose number e in a way that the derivative of an exponential function for which the base is equal to e would be itself, right? So the antiderivative for the function e to the x is one antiderivative for it is e to the x, and the most general antiderivative for it is e to the x plus c, right? Now, guys, I'm hearing some unexpected noise. Yes, but I don't know who is it from. Okay, now, no problem. Guys, yes, for the function, now, guys, now it is becoming important. So, uh, please pay closer attention. For the function f of x equal to x to the n, when n is not equal to -1, the antiderivative for such a function is what? Huh? The antiderivative for such a function is x to the power one increment of the power that we had over the increment of the power that we had, right? And in the most general form we add a c, right?
Yes.
That is very important. For example, if you have x to the 2, exactly like that one, yes. If we have x to the 2, its antiderivative is going to be x3 over 3, as your friend pointed out here. If we have x to the 3, the antiderivative would be x to the 4 over 4. If we have x to the 11, the antiderivative is going to be x to the 12 over 12. If we have a square root of x, which is x to 1 over 2, the antiderivative would be x to the power 3 over 2 over 3 over 2, right? If we
Yes.
have if we have 1 over a square root of x, which means x to the power minus 1 over 2, the antiderivative would be what? It would be x to the power 1 over 2 over 1 over 2, right? Yes?
Yes.
Very well. Now, this rule, which you are all familiar with from your high school years, is called the power rule. Yes? But
Yes.
it has one exception. This power rule can't be used when the power is equal to minus 1, right? If you intended to use the power rule when the power was equal to minus 1, you would have got 0 in the denominator of the antiderivative that you want to write. Correct? So that would be
Yes.
inappropriate. Yes? Now,
All right. This power rule for integer number, not for
not for the integers only. It is for,
just for natural,
huh?
just for natural number.
No, not just for natural numbers. Who is that? It was a very good question. Who is talking? Abbas. No, it is not only for natural numbers. For example, for 1 over 2, which is a rational number and not a natural number or an integer, the rule also applies, right?
Right.
Actually, actually, it is correct for every real number except for minus 1. Okay? If the power is equal to 1.5, no problem. You can still use the power rule. Okay? Very good question. Thank you very much. Now, what if the power is equal to minus 1? What are we going to do then? If the function that we have is x power minus 1, huh?
ln of x. ln.
Exactly. We've learned that in the previous chapter. The derivative for ln of u, you remember, was u prime over u, right?
Yes.
When u was positive. Now, the derivative for ln of x when x is positive is 1
Over x.
over x. And the reason why we put in this absolute value sign here is what? You can tell me? Can you tell me?
Mindful.
That is because the domain of a natural logarithmic function of the ln function is what?
0 to plus infinity.
0 to plus infinity, not including the 0 itself. Okay?
Yeah.
Yes. Very, very well. So, if the function that we have is f of x equal to 1 over x, it's one of its antiderivatives is ln of absolute value of x, and the most general antiderivative of that function is ln of the absolute value of x plus c. Okay? And here we have this constraint that this is true on any interval that does not contain 0. Yes?
Yes.
Very well. Now, if f of x is equal to x to the minus 5, we can still use the power rule, right? And we can write the antiderivative is x to 1 minus 4 over minus 4 plus c. Exactly. Uh, Said, can you remove this thing that is here? Huh? If you can, that would be a good help. Now, guys, in this example that we solved, example 3, we
It's writing like this. I think someone wrote this. So
whoever wrote it, whoever, if you
you can remove it
uh,
because you are the host.
I know I have to go to the whiteboard, it ruins the recording. No problem. We can.
You can also like put us on hold on mute. So
I know, I
because you
know,
are the host.
I know. But the problem is, if I work on that, the now I'm recording everything that is on screen on my screen. If I change my screens too much, it is gonna ruin the video that I'm recording. Okay, that is the problem. Now, in this example, example 3, we saw we saw a okay. Let me read your chats. Okay, I'm gonna share the screen. I had a lag in the
It's
Acrobat
possible,
Reader.
but send us like that.
Yes, I know, but what can you do?
Yes.
This is a special situation, right? It is not.
Math is not easy. So even in this situation, we should even put more
It is
effort to
Said.
study.
It is Said, right?
Yes, it is right.
So, Saidion, I know that is a little bit difficult for you and for me. It is not easy for me to teach like this. There are lots of things that I want to tell you, but it needs a board on which I write, and it is not available. So,
It should not only be. I mean, you can write on another thing, board paper or a small.
but how can I make you see it? Huh?
No, no, you can use another thing.
So, guys, are you seeing this? Very well. Now, please listen to me. Uh, in example 3, right, we saw a couple of rules actually, right? There are rules that can be derived from the parts of the example that we solved, right? Now, in this table that you have in page 4 of the second chapter, we see a table in which we have some famous functions and their general antiderivatives, right? Some of them are very familiar to you, and some might be not so much familiar to you. So, the first one is actually a theorem, and it says if the function is af plus minus bg, the antiderivative for the whole function is going to be equal to a times the antiderivative for f plus minus b times the antiderivative for g, right? Plus c. As that c is our uh, general constant. Now, the power rule is the second entry of this table. It says if you have the function x to the n and n is not equal to minus 1, its general antiderivative is x to 1 n plus 1 over n plus 1 plus c. If the function that we have is 1 over x, then the most general antiderivative for this is ln of absolute value of x plus c uh, when the interval on which the function is defined does not contain 0. If the function that we have is sine of kx, then its antiderivative is minus 1 over k cosine of kx plus c, right? Yes? If the function that we have is cosine of kx, then its most general antiderivative is 1 over k sine of kx plus c. Imagine that I've written this and I'm not sure whether or not I'm correct. What do I do? What is the solution to this dilemma? Huh? What? What? So imagine that this is my function and I've written the I've written an antiderivative for it. Huh? Like this, 1 over k sine of kx plus c. And I'm not sure about the correctness of my answer. What do I do? Exactly. You calculate the derivative of this. You see, yes, the derivative of 1 over k sine of kx plus c is cosine of kx. And your worries are going to be removed. Now, if the function that you have is 1 over cosine 2 or secant 2, then the antiderivative is 1 over k tangent, right? If the function that you have is 1 over sine 2 or cosecant 2, then the antiderivative is minus 1 over k cotangent, okay? If the function that you have is secant of kx, tangent of kx, then the antiderivative is 1 over k secant of kx. And I don't repeat c, okay? You have to always write it when it comes to the antiderivatives, right? If the function that you have is cosine of k, cosecant of kx, cotangent of kx, then the antiderivative would be minus 1 over k cosecant of kx plus c. Now, everything up to this point was a little bit familiar to you. The next three entries might not be as familiar, so you have to pay more attention to them. If the function that you have is 1 over a square root of 1 minus k2x2, then the antiderivative is 1 over k arctangent of kx. Sorry, arcsine of kx. Yes? So for example, if the function that you have is, guys, listen to me, this is a question. If the function that you have is 1 over a square root of 1 minus 4x2, then what is the antiderivative for it? If the function that you have is 1 over a square root of 1 minus 4x2, then what is the antiderivative for it?
I think 1 over 2 arcsine 2x plus.
Exactly. Thank you, Abbas. Exactly.
Always, always thank you.
Halvest, halvest. Your voices are similar. Now, if the function that you have is 1 over 1 plus 9x2, huh? The second entry, then what is the antiderivative for it?
I think 1 over 3 arcsine 3x plus.
Uh, I'm asking a question in relation to this entry. So I'm saying 1 over 1 plus 9x2. What is the antiderivative?
1 over 3 3x.
Arctangent of 3x. Very good. Very good. Now, if the function that we have is 1 over x square root of k2 x2 minus 1, then the antiderivative would be arc secant of kx plus c. Okay? When kx is bigger than 1. You can prove it easily. Actually, that is a good. Guys, listen to me. Listen to me. Uh, this is an exercise that you have to write on a paper and send me the answer to. Okay? You have to. You have to prove that the antiderivative for this function is this. Okay? Yes. Simple exercise. Okay? Very well. Very well. Now, if the function that you have is e power kx, e to the kx, then the antiderivative would be 1 over k times e to 1 kx plus c, right?
Right.
Abbas, what is happening to you? Your voice is on slow motion. Wow.
Teacher, please excuse me.
Go ahead, Ibrahim.
Teacher, please tell them when they have any opening and any notice, they can raise their hands, not make any noise. With my respect.
Uh, Thank you, Ibrahim. But yes, that stuff is gonna that stuff is gonna, uh, 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 distract me. You see? If you go ahead, if you ask any question, just interrupt me. Okay? That is easier for me. Okay? Okay, Ibrahim?
I hear you. Okay, okay.
Thank you very much. Now,
Understood.
if the function that you have is a to 1 kx, then its antiderivative is going to be 1 over k times ln of a times a to 1 kx, right?
Okay.
Now, I think Muslim had a question, right? Muslim has raised his hand. Yeah?
No, teacher, maybe it's the first time with this app.
What?
Maybe Muslim first time use this app. He felt
Uh,
like it's fun.
okay, 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 no problem. Thank you.
Muslim لسه بتضربني قلت يا
How are you, Kafa?
طلعت دقيقة ما بتعرف شنو.
Do you have any questions, my dear Kafa?
No, no.
Thank you, Muslim. Nice to hear you.
Sorry, teacher.
No problem, dear. No problem.
إمام استأذنتني عشان بس بقعد
Okay.
مرة.
Okay, guys. Now, this table that is in page 4 of the second chapter is very important, and all of you have to memorize it, right? Actually, if you you don't need to actually memorize it, but you have to have it clearly in mind. If even if you haven't memorized it, it is going to come to you because you know how to take derivatives quickly, right? But it is required from you to uh, have this table which covers the basics of antiderivatives clearly in mind. Okay? Now, we're going to solve an example using the information that we abbreviated and summarized in that table. Okay? Example 4 of page 5 says find if such that f prime of x is equal to f prime of x is equal to 1 over x plus 2x2, for example. What does that mean? The f prime, guys, please pay attention. In this example, example 4, the f prime is given to us. The f prime is given to us, and the function f is unknown. What does that mean? In order to find the function f, the thing that we have to do is to calculate the antiderivative for the f prime. Yes? I'm receiving noise. Let me find its source.
عبالكم سمعنا بتعب.
Okay.
الشيخ عندك.
So, if the function part A, if the f prime, the derivative function that is given to us is 1 over x plus 2 times e to the 2x, Then what is the function f of x? In order to find f of x, as I just said, we have to what? What's that? What? Rest time. Aha. Okay, actually, it is a good idea to have the rest right now because 4 minutes is remaining from the Zoom time, and and okay, guys, go away, and I'm gonna see you in 20 minutes. Okay? Very well. And I'm gonna send you a link for uh, the next session. Okay? Thank you very much. So, guys, are you listening to me? Very well. Now, uh, let us have a very quick recap of what we learned. I told you that an equation which contains the differentials or derivatives of an unknown function can be called a differential equation, right? Now, here we see a, a specific type of differential equations. Actually, this one is a very easy differential equation. Here, the unknown function that we're looking to find is the function y, and the derivative of this function y is given to us, and it is equal to f of x. So f of x is known, can be any single variable function of x. For example, 2x, sine of x, x2, cosine of x, any single variable function of x. Okay? Now, we are lucky actually, and the solution to this specific differential equation can be very easily found. And we understood that the solution to this differential equation is the antiderivative for the function f. And we wrote it like the capital case f of x plus c, which is the antiderivative for f of x. After that, we had an example, right? Oh. And in this example, dy over dx was equal to 2x. This was our differential equation. And the unknown function y, as we said, is equal to the antiderivative of 2x, right? Which is x2 plus c. Okay? So the solution to the differential equation that you see is y of x equal to x2 plus c. Okay? The point is, guys, listen to me very carefully. The point
Teacher,
is,
1 minute, teacher. Teacher,
what?
actually, and today I didn't understand the bycode. Teacher, I think it's better that you record the this and then send us to us. Send it to us.
I told you that I'm gonna do that. Yes. I am recording this stuff and I'm gonna send it to you. Yes.
Yeah, teacher, I know you, but it's you cannot sit on the screen 6 hours, 3 hours here and 3 hours there. It's going to be a lot of time. Side bycode.
Said boycott? Yes.
Bycode. Bycode the game.
Yes, I'm gonna boycott Said. Yes. Said, yeah. This is the timetable is set up by your department, right? And I have to conduct the classes according to the timetable, right? So,
Bycode is the best solution.
what can I do?
Bycode.
Okay. No, well, we're not gonna boycott anyone except for Said. Said, we are gonna boycott, but nobody else. So, Said Gyan, uh, what? I know it is. It takes a little bit too long, but it is too long for me also. So please,
I'm going to talk to Dr. Zagal and tell him that
each
some
day you have.
classes should be recorded and not like this. It's going to be better for us.
But even if I'm supposed to record it, I can't record it any other way. I don't have the necessary equipment. You see? Sorry. So, uh, but all the other stages have absolutely no problem with the uh, shape of the class. I hope, Said Gyan, that you also bear with us, and we understand that it is difficult for you to understand what is going on this way, but there are advantages to this also, and the advantage is that you're going to have the recording of the class at your disposal. In the physical classes, you didn't have that luxury. Now you can go over the class uh, into the recording over and over again, and you have unlimited access to what is being said on your class. I think that is a positive. So let us continue. And uh, yeah, the very important point that we have here is that this solution y of x equal to x2 plus c has an unknown constant in it that is undetermined, right? Whatever number you put in whatever number you replace c with, for example, 1, 2, 3, 4, whatever that unknown constant c is, you're gonna have a different solution. Huh? So this solution y of x equal to x2 plus c for the differential equation dy over dx equal to 2x is actually a number of solutions. So here actually you have found an infinite number of solutions for this differential equation. Yes? one for every C. Because of this, because of the flexibility that we have here with this solution that contains an undetermined constant, this type of solution is called the general solution to our differential equation. And I emphasize on the word general. Okay? And this is a concept that can be generalized. Every solution to a differential equation like this one that contains an undetermined constant C is called a general solution to that differential equation. And I'm going to write that down here. Okay?
I miss classroom. I miss classroom.
Said Gyan, quiet. Okay?
مستعد.
Okay? Questions? This thing that I pointed to is very important. So this is the definition of a general solution. Every solution to a differential equation that contains the undetermined constant C is called the general solution. But the question is, how, how do we determine the undetermined constant C? That is the question, right? Look, guys, do any of you have an idea on how to do this? For example, this is our differential equation, and the solution, the general solution that we find is y of x equal to x2 plus c. How can we determine this undetermined constant c? Huh?
If you give y and x 2 point, 1 point.
Exactly. Who said that?
Abbas Hussein.
Thank you very much, Abbas. Thank you. Very, very, very good. So, as Abbas said, in order to determine the value of C, we need to have the value of y at one specific x, right? For example, if in the equation above somebody told us that the value of y at point 0 is equal to 1, then we could then we could easily determine C, right? Do you all agree?
Yes.
Guys, I honestly think that this thing that we're doing here is better than a whiteboard and a classroom, right? It is just like a classroom. You see, I'm writing everything. You're gonna have everything that you need. What's the problem, Saeed? Huh, Saeed, answer me.
Teacher, I don't have a personally, I don't, as I'm studying. المشكلة من غير ليني أنا.
You see, it is better than a whiteboard. Huh?
Yeah, but teacher, I think it's very boring to watch it live and then watch it again.
Life is boring, Saeed. Life is boring. Sorry. Go talk to
I can't
Corona.
watch it twice. Teacher, I can't watch it twice. Watch the live
You
and
have to
then watch it
try.
again.
I'm gonna give you the YouTube link. Okay? I'm gonna give you the YouTube link. I'm gonna upload the video on YouTube and you can watch it as many times as you like. Or maybe you don't like to watch it.
If I don't come, you will يعني غياب لي, right?
Yes.
So I should be here غصبا عني and if
So Said. Okay.
Dark side.
I muted Said. Okay. Sorry, Said. We have to continue. This is what we can do in this quarantine situation. Go talk to Corona if you have a problem. I didn't create this situation. Corona did. Okay. Shuan, what are you saying? How can it be not boring?
Mute anyone who offers your opinion.
Yes, I'm gonna do
Mute anyone who stops you.
that. I'm gonna do that. I'm gonna do that. Okay. Guys, it is not my fault. What can I do? So, uh, guys, now, in order to determine the value of c, we need to have the value of y at one specific x. For example, y at 0 equal to 1. Then we could easily determine c, right? Now, Abbas, can you answer me by considering the value of y at 0 to be equal to 1, then what is the value of c?
One.
Exactly, exactly. How did Abbas answer that? He said the general solution says y at every x is equal to x2 plus 1 plus c. So at 0 also, we can say y at 0 is 0 to the 2 plus c. And 0 to the 2 plus c is equal to c. On the other hand, we know that y at 0 is equal to 1, right? Yes? By comparing these two, we can conclude that c has to be equal to 1, right? Yes? Do you all agree?
Yes, teacher.
Very well, thank you. So, now that the value of C is determined, now that the value of C is determined, we can say y of x is equal to x2 plus what? Yes, x2 plus x2 plus 1, right? Guys, do you hear me?
Yes, teacher.
Very well. So, guys, are you all with me at this point? Stop chatting. Listen to me. Do you all agree with everything that went on up to this point? Y of x is equal to x2 plus 1. Now, this one is called, this is one of the general solutions that satisfies this condition. Okay? This condition, we're going to call it the initial condition. Okay? We call this condition that we have on the value of y the initial condition. And this specific solution that satisfies the initial condition is called the particular solution. The particular solution. Yes? Now, what is the official definition of
Teacher,
a
define
particular
the particular.
solution? What was the question? A little bit is left. Let me finish this, and we're gonna finish off the class. Okay? Now,
Teacher, say hand.
so guys, are you with me? The particular solution is the solution. Look at the screen, guys. The particular solution is the solution among the general solutions that satisfies among the family of general solutions that satisfies the initial condition, right? So all of these solutions x2 plus c satisfy, yes, all of these solutions x2 plus c satisfy this differential equation but only one of them, which is x2 plus 1, satisfies this initial condition. We call that solution among the family of general solutions the particular solution. Okay? Did you understand? Questions?
Teacher, please mute Muslim.
Muslim? What is Muslim doing?
11 o'clock, teacher.
Muslim, answer to me.
11 o'clock, teacher.
Is that you, Muslim, who's talking?
Yeah, he just now say to it's 11 o'clock, teacher. He's
Okay.
now
Okay. The class is over, and we're gonna talk a little bit after I finish.